Welcome back. In this episode, we're going to change this into a noise field generated piece of terrain. Now, we haven't built the thing where we actually extend off into infinity yet. We're going to do that next episode. This episode, we're going to make the noise field terrain, and I think that's going to be a lot more fun, so strap in tight. The problem with using Perlin noise for this is that Unity's Perlin noise generator is two-dimensional, and that's just no good. You need a three-dimensional noise field or no noise field at all. Noise fields are actually also very, very limited in terms of how they function, so you're going to need brushes either way, but let's not get into that. Let's just do the noise field. While Unity doesn't include any natively, other than the two-dimensional Perlin noise field, there are plenty of them out there in the wild. Here's one such, here in Google Code. This is, I think it's public domain. I know it's shareable either way, so it's included. I'm going to put the link in, and I'm also going to go ahead and put it into my project. I'm going to put it into my project right now. So this is what's inside the zip that you get, and this is the only file we care about. So let's go ahead and drag that into our project. Noise. Yep. So if we open this up, we can see that it actually, it's over here. We can actually see that it says free and unencumbered into the public domain. So thanks to Heikki Tormala, this is a pretty good implementation for our purposes. It's a lot more blobby than a Perlin noise field, but that's actually good. We're going to like that. So this is just going to be great. And the way we work is very simple. Once it's in the project, it just works. You want to see how this works? Watch. Voila! You can even reference it without that by saying simplex noise dot. So the noise field generator doesn't have a necessary, as I recall, I've used this before, but it's been a while. As I recall, it doesn't have a required instantiated noise class. Maybe it does. Let's find out. So let's go ahead and say noise dot generate. No, you don't need one. So just noise.generate, and then you can see that there's a one-dimensional, two-dimensional, and three-dimensional version. Now, we have to be a little bit careful because this system, you don't want to feed it integers. If you do, you're going to be very disappointed in the result. Similarly, we don't actually want to feed it our coordinates in question, but we're going to get to that later. So we're going to go ahead and make a for z equals, and we're going to have for y equals blah 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 blah. So map xyz equals something, but what does it equal? It doesn't equal 1, I'll tell you that. Float noise x equals, we can actually put this out here. Float noise x equals float x divided by 10, that's 20. Float noise y equals float y divided by 20, divided by 20, not divided by equal to, and float noise z equals float z divided by 20. Then we can say byte brick equals noise.generate float x, y, noise x, noise y, noise z, like so. This is actually float noise value. And then we're going to say if noise value is greater than 0.2, then we're going to set it to solid, otherwise we're going to leave it empty. Shall we see what that looks like? First things first, this guy is going to get, we're not going to be able to use his camera. It's just not going to work out for us, but it's okay. We should be able to just see it. See? Beautiful. Awesome. It's such a thing of joy and beauty, and it was so easy. This is the great thing about noise. Noise just works, but the problem is that it just works in one dimension. These are just bricks. They're not sand, water, gold. They're just bricks. So you need to implement a lot of weights in order to, differentiate between different kinds of bricks. You can't do things like trees very easily with this. There's a lot of restrictions as to things like mountain ranges where there's a lot of contiguous bumps. This doesn't really do contiguous bumps very well. But On the other hand, it just works. So what we're going to do to polish this a little bit is, first things first, we're going to make our block size much larger, just so that we can see it in a lot more action. And the other thing we're going to do, now that's the simplex noise field again, I already showed you that. This is what I need. The other thing we're going to do is, when we do this noise value, we're actually going to divide it by, or rather multiply it. No, divide it. We're going to make it so that when it's near the ground, it's more likely to be solid. So, yeah, multiply. Sorry, I keep getting confused as to whether y is up or down. Too much work with textures. Y going up, it means that it should be less likely to have a value, so we should be dividing by y. So we say noise value divided by equals y. Float y divided by 5. And we can tweak that later. We can make it adjust to height or whatever we would like. Let's go ahead and see what that looks like. It looks like nothing. Oh, we made it too large. Our culling is not effective enough to handle that height, that size of chunk. So we'll just reduce it a little bit. There we go. And here you can see that we have a very effective chunk. Don't worry about the way that the scene camera clips through things. That's just the scene camera's way of saying it loves you. But you can see that we definitely didn't do this well enough because the ground is still fall-throughable. So what we actually need to do is we need to add a certain value rather than simply multiply by a certain value. And you can see that the top is still too opaque. So that wasn't enough of an edit. We need to make that significantly more aggressively modulated by y. So, let's go ahead and say that noise value plus equals 5 minus y divided by 10. Come on, don't click when I want you to not click. There you go. Wow, it did make it so the top is no longer terrible, but the bottom wasn't added to enough. So let's go ahead and add more to the bottom. So make this 10f minus float y. There we go. That's more like what we'd like. And of course we can refine this forever and ever and ever. But a big key here is that we already have a working collider. So let's go ahead and move this guy up above the surface, and we can just wander around this map that we've created. And hey, if you're really impatient and I haven't uploaded the next episode, you can now go back to my previous system and do all of the work with the textures and shit. And you can actually end the clicking and the making things add and delete and in going off into infinity. All of that stuff is going to be largely the same. Da, 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 da. Alright, that was not too bad. I hope you enjoyed this episode. Tune in next time, and we'll make this landscape go on forever.